Oh, hello, this is Mr. Precella. Today we're going to be solving exponential and logarithmic equations, and we started solving exponential equations a week ago, and we were using the same base technique, and the natural question was, well, what if we couldn't get a common base? Like this 3 to the x equals 7. There's no way we're going to write 7 as 3 to a power. Unlike 9, we were able to write that as 3 squared. I think that'll be the first one I do as an example. I said that we'll use logarithms, and it's now next week. We're going to use logarithms to solve these. So the first thing we'll discuss is how to solve an exponential equation where there's not a common base. To solve an exponential equation in which there is no common base, I'm going to follow 3 steps. First, take the natural logarithm of both sides. I'll write take the ln of both sides. I'm writing it like that with a capital L because I think that's how most of the calculators have it labeled. Okay? That's a real easy step. All you do at that point is just stick ln in front of each side. Then use the power rule of logarithms to carry down the exponents. There might only be one exponent, and then the third step sounds easier than it is. Isolate the x value. And maybe we better put a note there. If there are two x's, isolate them on one side. So if we have an x on each side of the equation, then isolate them on one side. The side I'll always use is the left side, but it'll be up to you. Then factor out the x's and divide. What I mean by that will become clear as we're actually doing an example. But before we do an example, let's solve that problem that I'd asked about over here a week ago. How would we solve 3 to the x equals 7? So here's an example. 3 to the x equals 7. I'm going to follow these steps here. First thing I'll do is stick an ln in front of each side. So I have ln 3 to the x equals ln 7. That's step 1. Now, use the power rule to carry down the exponents. There's only one exponent, and the last time we said that with logarithms, if you have an exponent at the end of the logarithm, you can move it down in front. So we're going to have an x. I'm going to go ahead and write my L in cursive now. X ln 3 equals ln 7. Why? It's not my habit to write it like this, and I keep wanting to write it in cursive anyway, so I will. And now the last step. We've got to isolate the x. You know what? It'd look better if I just said isolate the x. There. How would I isolate this x? The operation that's going on here between x and this decimal number ln3 is multiplication. What can I do to both sides? If this is x times ln3, what can I do to both sides to isolate the x? Divide by ln3. So, what's our answer here? Well, x equals ln7 over ln3. You cannot cancel the ln. And it's actually going to be a decimal number. Let's round this to 4 decimal places. ln, remember the last time we said if the calculator opens a parentheses when you press the logarithm button, you enter the argument and then close the parentheses. Divided by ln, you punch in the 3, close the parentheses. I remember the old TI-81 did not open parentheses.
The 85 didn't either.
Okay, but most other TIs, when you press ln, it's going to open a parenthesis. You type in the argument, close the parenthesis. Okay. And this reminds me of what we were doing with the change of base formula in the class the last time. So we're going to round this to 4 decimal places. Read the instructions carefully because I think they don't all say round to 4 decimal places. Some of them they might say round to 3. So it would be a 1.771. Is it staying a 2 or going up to a 3? Staying a 2. Mm-hmm. The digit after the 2, if it's 4 or smaller, then you just drop them. If it had been a 5 or bigger, you would have rounded it up. So 3 to what power is 7? 1.7712. Right? I think problem number 1 in the homework assignment is similar to this. Let's see. Let's actually do one of the homework problems. Uh-oh. Do you think it's did we talk too long without clicking? Oh, here it comes. Here's problem number 1. Very similar to my made-up example, the one I made up a week ago. 3 to the x equals 5. Notice it wants it rounded to 4 decimal places. Oh, okay. Well, maybe all of them. Stick ln in front of each side and carry down that exponent. So we have x ln 3 equals ln 5 divided by ln 3. Now don't get carried away canceling. You can't cancel ln's. Don't try to cancel the ln and say 5 over 3 is your answer. But, so we have ln 5, close parentheses, divided by ln 3, close parentheses, equals 1.46. Is that going to stay a 49 or go up to a 50? Okay, that 7 is 5 or more, so 50. So 3 to the 1.4650 power will give us 5, huh?
So if that's above 5, you just round it to a 0?
No, you round it up. Well, if it is a 5.
Okay, so it would be 50. So I got it. Absolutely, I'm picking up.
Now, how does problem number 2 differ from problem number 1? Well, in problem 1, there's only one x. How many x's are there in problem 2? There's 2 different x's. So this is interesting. We could have solved it with the common base method. Oh, well, still do it using logarithms. Okay. I'd never seen that happen before. 4. Do y'all see what I spotted? 2 can be written as 2 squared. So this taking the natural log of both sides will work even for equations where you can get a common base, as we're about to see. You're just going to have a little bit messier stuff to punch in. No, check number 3, make sure that there's no common base for number 3 also. No. Okay. No, but okay. I bet you some people on number 3 would try to get a common base. What would they do? The common mistake, say 6 is 3 squared. Yeah, but here on number 2, you could convert that 4 to a 2 squared and solve using that method we saw a week ago. But as it is, we're going to take the natural log of both sides. Tim, can you put it? Well, okay. Now, there's 2 different x's here, so that sentence that I have right here becomes important. If there's 2 x's, when you're doing step 3, it's not going to be so easy, okay? If there's 2 x terms, you isolate them on one side. I always move them to the left. Factor out the x's and divide. So that's going to be important when I'm doing the 3rd step here. First thing I'll do is stick ln in front of each side. So I'll have ln 4 to the 7x minus 2 equals ln 2 to the x. Step 2 is where we carry down the exponent, and this is going to be sort of tricky here because we have 2 terms in this exponent. When we carry it down in front, we need to put it in parentheses because both the 7x and the 2 are being multiplied by ln 4. Over here, you just carry the x down. Okay. So we carried the carried the exponents down in front using that power rule. And both the 7x and the minus 2 are being multiplied by ln 4. So what we're about to do is distribute the ln 4 the same way you would distribute just a variable. Just stick ln 4 after each one of these terms. We'd have 7x ln 4 minus 2 ln 4 equals x ln 2. 7 times x times ln 4 is just 7 times x times ln 4. Minus 2 times ln 4 is just a minus 2 times ln 4. You are not changing the arguments. There is something you could do to change the arguments, but I can't imagine why you'd want to. You could take that 2 and move it where? Up as an exponent, so you have a 16, but I would not recommend doing that. Here's something you'll want to remember. When you take the natural log of both sides, you have an argument of 2 and an argument of 4. Those arguments should not change. Your final answer that you're punching into your calculator will have ln 2s and ln 4s. They can't have ln 8s. They can't have ln 6 or anything like that. What you're going to be punching in will ultimately involve ln 2s and ln 4s. Just like on number 1. Look at number 1 right here. You wound up with an ln 3 and an ln 5. You can't wind up with an ln 15. You can't wind up with an ln 2. Only ln 3s and ln 5s and the stuff that you're punching in. Okay? Let's go back and finish it. Okay, if there are 2 x's, isolate them on the left side. So here's what I'm going to do. I'm going to move the x ln 2 over to the left, and the term that doesn't have an x, the 2 ln 4, I'll move it to the right. So we have 7x ln 4. What I'm doing right now is isolating the x terms on the left. Okay, so isolate the x terms on the left. I subtracted x ln 2 from both sides, and I added 2 ln 4 to both sides. Now I need to somehow get it to just a single x. And the way I'm going to write this so that there's only one x, after I isolate the two x's on the left side, factor out the x's. Remember how to factor out a variable? You just write down the variable x. And what's going to go in the parentheses? If I factor 7 ln 4, that's right. Then a minus what? ln 2. I factored that variable out of each term.
And where you put your circles, the red circles, what are you?
The red circle is moving the x term that's on the right to the left. That's how we got this second term here, the minus x ln 2.
So subtracting x.
Subtracting x ln 2.
Okay.
And then adding 2 ln 4.
So
to get the thing.
Subtracting the whole thing, subtracting.
I'm subtracting all of this. This has to stay together like that.
Okay.
And it's over here. And this is the term that doesn't have an x in it on the left. I'm moving it over to the other side. I want only the x terms.
Okay.
I'm moving all of that, which would be adding 2 ln 4. This is all one term. That minus 2 ln 4, that x times ln 2. They have to, if you're moving them to the other side, you have to move the whole thing. 7 ln 4 minus ln 2. That is a messy decimal number. I can punch it into my calculator. It's x times a messy decimal number. But we know what to do to get rid of a messy decimal number multiplied by x. What's going to undo that multiplication? Divide. And the coefficient of x is 7 ln 4 minus ln 2. So I'm dividing both sides by 7 ln 4 minus ln 2. And that gets the x completely isolated. And now we have to figure out my mind went blank. We have to punch this in. How do we punch this in to a calculator? If you have a fraction that you're trying to punch into a calculator and it involves anything other than the operation division, something divided by something, then you're going to have to assume parentheses around the numerator and the denominator. I was going to let them figure that out. Notice I see different operations, not just division. There's multiplication, there's subtraction. If you have any operation other than just division in a fraction, 5 divided by 3, ln 2 divided by ln 7, something like that. If you have any other operations, you're going to have to enclose the top and bottom in parentheses. So left parenthesis. This parenthesis I'm about to write is that red parenthesis Tony just put there. 2 ln 4. When I press that ln, it opened a parenthesis. So I have to close this parenthesis here, and I have to close that red parenthesis that there's the numerator. 2 ln 4. Now, if you don't put those two parentheses right there, whatever you do the rest of the way, you're going to get the wrong answer. Divided by, left parenthesis, 7 ln 4. Okay. It opened parentheses, so I close the parenthesis. Minus, and realize that thing right there is a minus. Don't use the negative sign. That is a minus ln 2, close the parenthesis after the 2, close off the denominator.
Do you need the parentheses on their place?
Well, now, this particular model will not, if you don't enclose the final parentheses, if you don't close them off, they won't give you a syntax error. Some models will give you syntax errors, okay?
It's over the 4 as well, so I was making
It's got to be. And you've got to have these two parentheses right here. If you don't have those parentheses there, you're going to get the wrong answer. If you don't close this parenthesis right here, you're going to get the wrong
parenthesis
answer.
that's opened needs to be closed. On top, we have that left parenthesis, so we had 2 closed off. Then we opened a parenthesis for the denominator. The calculator opened a parenthesis for that argument that we had to close, minus, they opened a parenthesis for that 2, close after the 2. That last parenthesis is closing the parenthesis in front of the 7, equals.
Years ago, I remember a teacher saying in a programming class, if you've got to have the same number of open parentheses as closed. On top, we have 1, 2 open. We better have 2 closed up on top. On the bottom, we have 1, 2, 3 open. There better be 3 closed. 1, 2, 3 on the bottom. None of these parentheses are optional. If you think you can get the answer without putting the red parentheses, you're going to get, yeah.
But the TI-83, I will give them credit. If you don't close the last 2, they'll still give it. They'll close it automatically, and it would give you the correct answer. That is a very bad habit to get into, leaving what's called dangling parentheses.
Okay,
Open
let's
a
see, how do they
parenthesis,
say
shorter.
to round it?
3 decimal
3 decimal places. Okay, so .30. Is it going to be a 7 or an 8?
8. Traditional rules of rounding. 5 or higher, you boost up the previous digit.
Okay. 3. Okay, this is the one that has the 6 and the 3. 6 to the x plus 1 equals 3.
I tried to punch it in on my calculator 3 times and it still just keeps telling me quit.
Oh, let me see. You're not.
So I just cleared it now.
Oh,
I'll try it one
you
more time.
missed a parentheses.
Missed a parentheses. Punch it in. Your calculator, you should punch it in exactly the way I have it here.
Yeah, that was like copied it exactly.
No. You missed a parentheses.
Or else, probably, if you put a negative instead of minus,
you may have
that
put
might
a
have.
negative. No, that would just count as multiplication.
I guess.
Okay, we've already mentioned this one. For a second, it looks like you can do use a common base, but no, you can't.
Wait, don't erase. Let me see what.
It's just frustrating because I'm literally
2 ln 4 divided by. No. You've got to have a parentheses in front of that 7. Let's see. Second entry. I'll go up here. And second insert.
So there has to be a parenthesis.
Yes. There should be as many parentheses open as closed. 2. Now, put the parentheses in front of the 7. You're missing that red parentheses in the bottom. And I had it written as red parentheses. Let's see. You might think we're overdoing it with this parentheses stuff and the calculator, but 99% of the people that miss these problems, it's because they're messing up with the parentheses. So let's do number 3, Tim. Show my work. I'll stick ln in front of each side and carry down the exponent. So we have x plus 1 ln 6 equals 2x minus 2 ln 3. Oh, I should have mentioned, if you had done this with a common base, you would have wound up with a fraction, just a pure fraction, rather than
and you would have had to convert it to
a
a decimal
decimal.
because they did want a decimal.
decimal numbers. It's one of those rare times where they want decimals. Now, let's distribute. It'd be an x ln 6 plus 1 ln 6. I think I'm just going to write ln 6. Okay. And over here, we've got to distribute 2 because there's these two terms. The exponent was two terms, so we have 2x ln 3 minus 2 ln 3 so
Get all of the x terms on the same side. We already have an x ln 6 on the left. What are we going to do with this x term?
yeah.
Okay, so subtract it.
And what am I going to do with the ln 6? Because there's no x on the ln 6, so subtract it. So we're going to have x ln 6, and then it's going to be a minus 2x ln 3. And if I move that over, it's going to be a negative 2 ln 3 minus ln 6. Y'all
Now
hold
we-
up?
Trying to stick on.
I'll move the x terms around. You get the 2x, if there's 2x terms, you put them both on the left side. Every term that doesn't have an x should be on the right. That's why I subtracted the ln 6. And at this point, we need to go from 2x's down to 1. Say it again. Factor that x out. If I just factor the x from each of these terms, I'd have an ln 6, then a minus 2 ln 3, and divide both sides by ln 6 minus 2 ln 3. ln 6 minus 2 ln 3.
Okay, where are we going to need parentheses when we're punching this thing in? Well, we need it around the top and the bottom?
If there's more than one number on top, enclose it in parentheses. If there's
Okay, we're going to have to enclose that 6 and
the 3. Oh, it's going to be messy. So right here after the 6, you've got to put 2 parentheses. Okay. And down here, it's got to be this parentheses and that. Now, if on some calculators, not many, but some, when you hit LN, it won't open the parentheses. If yours is one where when you hit LN, it doesn't open the parentheses, then
you don't have to put it around the
ignore the
argument.
green parentheses.
Realize that is a negative 2. Common mistake, people hit that dash there. You only use that dash for subtraction if you have something in front of it. Like right here, something minus something. That's a negative 2 ln, it open the parenthesis, close it off after the 3, minus ln 6, close the 6, close the numerator. There's the entire numerator. divided by left parenthesis ln 6 close minus 2 ln 3 close.
Close.
So how come you don't close the 3, or I mean the 2, I'm sorry?
That's not an argument. That's 2 times. You mean this 2 here?
I guess if you wanted to put that two
Could
in
if you wanted
parentheses,
to, but there's no need to.
the only reason we're putting the parentheses is the calculator's opening them.
I wouldn't be putting the parentheses around the 3s if they weren't automatically being opened.
Well,
There's
let's
no-
run 85 calculators. See how 85 doesn't open them. I
So if
remember.
it's in front, don't worry about it, but if it's
I mean,
No.
well, you can if you could close 2 as a factor. You could close it in parentheses if you wanted to, but it's just not necessary. 2 times ln 3.
The only ones that are absolutely necessary, regardless of the type of calculator, are these blue ones here. The ones on top, the one on bottom. All the other ones, these green ones, I'm only putting them there because the calculator
Is
opened those parentheses. And so I've then got to close them. And nothing's opening parentheses around when you type minus
it's like every
2.
time you push the LN.
When you hit LN, if your calculator, and it does, then you've got to be closing them also.
That makes sense.
If you have a calculator that doesn't, when you hit LN, if it doesn't open the parentheses, I'd love to know it.
Round to the nearest thousandth. How many decimal points is that? How many decimal
It doesn't
points?
say round to the nearest, 3 digits, round to 4, nearest thousandth. Do y'all remember how place value works?
Yes,
First,
tenths, hundredths,
hundredths,
thousandths. So they're saying round to 3 decimal places. The answer I have is 9.83. Is that going to stay in 8 or go up? It stays in 8.
Correctly on here. And then up.
Oh. Oh.
Okay. So,
Parentheses.
right.
Hey, wait, let's look at this.
Any questions there?
Oh, you were doing that one there. Divided by. Not, oh, what?
No, I was on-
9.838. Let me write that down. Mm-hmm.
It was on this one. I was trying to close off
Mm-hmm.
this,
Uh-huh.
and it wouldn't let me put the double, but it let me put the double
Let's see.
on the last one.
So,
Now, number 4, if you remember what we were doing at the end of class the last time, something involving inverse functions, this number 4 is going to work out very nicely.
okay. In fact, a week ago today, we did look at some common base problems, and we said, okay, if there's an E in the problem, that has to be the common base. Slide 13. This one here, if there's an E on both sides, that's the common base. And we asked at the time, well, what happens if there isn't an E on both sides? And I said, we'll use logarithms, and it's time for us now to, let me draw this mark. It's a good thing that I've started this problem so low on the page. What does that mean? Am I expecting it to be a real long problem? No. Okay. Well, there's no common base, so do what we did up here. On the other one, stick LN in front of each side. And this is going to work out easier than the others. Why? What do we know about ln and e when they're side by side? They cancel.
Good.
So this ln and e we cancel, and we're just left with a negative 0.33t equals ln 0.21. Now how do I get the variable by itself? With not just divide. Get the t by itself. We divide both sides by negative 0.33. Now, if there's more than one number on top in a fraction, you need to enclose the top in parentheses. If there's more than one number in the bottom of the fraction, you need that in parentheses. Here, there's only one number on the top, that's 0.21, and there's only one number on the bottom. So this one, you don't need parentheses around the top and bottom, but does that mean we're not going to need any parentheses? No, because when I hit ln, it opened the parentheses. So you've got to close the parentheses. Okay, when you hit ln on your calculator, it opened the parentheses. Oh,
Well, how do they want it round 4 decimal places?
Oh, okay. So let's see, t, rounding to 4 decimal places. 4.72. Is it going to be a 9.2 or 9.3? How would y'all round?
9.2.
9.2. And you'll notice those wavy equal signs. That just means approximately equal. We haven't done a lot of decimal approximations this semester. I think this is the first time we've seen those wavy equal signs, which just means approximately. Oh, well, here,
You're right.
Hey,
We did it the last
they
time.
put equals. They didn't write the wavy. I thought they were writing the wavy ones. Mm-hmm.
So there are 2 methods of solving exponential equations. If you can get a common base on both sides, great. That gives a rational solution for the equation. If you cannot get a common base, or even if you don't, you could get a common base, you just don't see how. This taking the log of both sides, preferably the natural log of both sides, is an excellent method of solving
It's going to
exponential
give you
equations.
decimal solutions.
Correct.
Mm-hmm. Okay. So,
Any questions there? Logarithmic equations.
we sort of did those the last time.
If it doesn't tell you where to stop, like the thousandth place or the 10th place.
If it's rounding, you have to
It has
stop.
to
It
say
has
it.
to tell you.
Like on number 5, it doesn't tell you how to round.
You're not going to have it. You're going to get an exact value.
Thank you.
Where it says that. So then
They all say where the to round to 4 decimal places, or look at number 3. Round to the nearest thousand. So they have, if it's rounding, they have to tell you where to round.
Mm-hmm.
And the fact here on number 5, they're not telling you how to round this. So, in that event, the answer should be exact. You should not have to round.
Mm-hmm. Let's look back and review something from the last time. We were solving log base 3 of x equals 2. Log base 3 of x equals 2. And I said we could do that by canceling out the logarithm by putting a big 3 on each side and using that common base rule. If the base on the logarithm and the base on the exponent are the same, all of those cancel out. Having seen that, you know how to do problem number 5. I didn't write it down. I should have. What was number 5?
Log base 3,
Log base 3
left parentheses, 4x minus 6, right parentheses,
equals
4.
4. It says solve for x. We want x equals a number. Yeah, whatever this base is, You put that base on both sides.
Right. Everything in the original problem is becoming exponents.
All the black stuff is now an exponent. Well, except for the equal sign.
Whatever is under the log.
That's an exponent now. This is the base. That's an exponent. By having the same number here and here, all of that cancels out, leaving just the 4x minus 6. Don't say 12.
3 to the 4th, 3 times 3 times 3 times 3 is 81.
Oh, it's 4 to the third power.
No, it's
No.
3 to the 4th power. If you multiply it out 4 threes, that's not multiplying.
3 to the 4th power.
It's not 9 times 9.
No.
Well, here
This is a
how do we
linear
solve this? How would you go about isolating the x?
Add
What would you do
6.
first? Add the 6. So we have 4x equals, instead of 87, and then divide by 4. 87 over 4.
So we come over here, circle the answer. I'm patching in 87 over 4. Notice there's no aliens in the answer. There's no approximation. Just 87 over 4.
Now, let's look back at that answer to possibility B.
Oh.
It says the solution is not a real number. It's possible that you'll go through this and solve for x and get numbers that aren't solutions. In general, after a logarithm, you've got to always have a positive number. Switch it.
We said that the base of a logarithm has to be positive, but not 1. A positive number to any power will always be positive. So not only does the base have to be positive, the argument must always be positive as well.
If
I
you
remember the old TI-80 calculators, the first generation graphing calculators, didn't they automatically convert, if you had the log of a negative number, didn't it convert it to complex numbers? That was a doozy.
Tim, let's look back at problems 1, 2, 3, 4. I should have already mentioned this, because I think most of those gave them the option of no solution or not. You see, what would have happened? Why might there be? When would you have chosen that option B of no solution or empty set? If when you were typing this stuff or punching stuff into your calculator, if you had gotten, let me see, this error warning, non-real answer. And that happens when you have a negative number after a logarithm or even a 0. Okay, there it just says domain rather than, which is trying to say you can't have a negative number or a 0 after the logarithm. Okay?
The negatives or zeros?
You can't have negatives or zeros, only positive numbers. Okay?
For the argument of a logarithm.
So,
Suppose we had solved this equation. Go back to this equation we just solved here. Suppose we solved this equation, we'd gotten x equals 1. If you plug in 1 there, 4 times 1 is 4 minus 6. 4 minus 6. Is that argument positive? 4 minus 6. No, it's a negative 2. So we would have had to discard x equals 1.
So are you saying you've got to check your answers when solving logarithmic
You got to make
equations?
sure whatever you get for x doesn't give you a negative argument.
Yes.
So in that sense, you do have to check. It's not as bad as checking those square root equations where you had to manually go through and make sure the left side equals the right. But whatever you get for x, you're going to have to look back at the arguments of the logarithm and make sure if you plug it in, You're not going to get a negative number. This thing here, it's over 20. You can easily convince yourself 4 times a number over 20 minus 6. Yeah, that's positive. Well, heck, the 4's cancel, so 87 minus 6. Yeah, that's positive.
Now, so make sure that your answers do not make the number after the logarithm negative or 0. Usually, not always, but usually that means mark out negative answers.
But not always.
Not always, but usually. Let's do number 6 and see if there's one that we can mark out on that one.
But realize this idea of introducing a common base and canceling out a logarithm, that only works if the base is and the logarithm are consecutive. You can't have another logarithm stuck over here on the left side of the equal sign, which means it can only be one logarithm on each side. You can't have more than one logarithm on the left or one logarithm on the right.
We know how to solve it if there's one logarithm on the left and a number on the right. The most basic problem-solving strategy is, when you're confronted with a new problem, try to make it look like the old one. Problem number 6. Hey, it doesn't have the little base there. Do y'all remember what that base is? If it just says log,
LOG, what is it? 10, that's right.
See, on this problem, there's an extra step that we didn't have on problem 5. On problem 5, we just had one logarithm equals a number. Well, we have 2 logarithms here. We need to rewrite this with just one logarithm. We can solve this equation if this is just one logarithm over here. So
you're going to have to remember how to condense logarithms from Monday.
How do we condense logarithms?
The logarithms are being added. So we write the LOG notation. Do I need a fraction bar here? No, because the logarithms are added, not subtracted.
If this plus had been a minus, would we have needed a fraction bar? Yes. Okay. So we don't need a fraction bar. Then all we do is just write x times x minus 15.
If the logarithms are subtracted, you divide the arguments. If the logarithms are added, you multiply the arguments.
So now,
what did y'all say the subscript was down here that we don't see? 10?
I'm going to go ahead and write it. If you don't see a base for the logarithm, we assume it's 10. So what big number do I need to put on each side? 10.
10 to the log base 10, they're inverse functions. What happens? Cancel.
How did we get the 10?
That was one of the things from last time. If you have an LOG and there's no subscript, we assume it's 10. Just like if you don't see a coefficient, you assume it's 1. If you have LOG and there's no subscript, you assume 10.
That the small number. For every logarithm, there has to be a base. Like here it was log base 3. But log base 10, you don't have to write, but you assume that there's a little 10 there.
Okay. And so what are we going to have on the left side once we cancel out the exponential and the logarithmic function to the base 10? Oh, well, we already got it, x squared minus 15x. I agree, distributing. What are we going to have on the right?
Don't say 20.
10 squared 100.
Oh, it seems like a long time since we've solved quadratic equations. There's an x squared, so it's a quadratic equation. I'm going to try to get 0 on one side and factor it. So we'd have x squared minus 15x minus 100 equals 0. 1 times 100, 2 times 50, 4 times 25, 5 times 20, or 10 times 10. Which pair of numbers do y'all think will work out? 5 and 20?
It's a simple trinomial, so you choose the pair that adds or subtracts to give you this number here. In this case, it's going to what? Subtract.
Say it again. Minus 20 and plus 5?
I agree.
Now see how it's factored? If you FOIL it out, x squared, then we'd have plus 5x and minus 20x. That's giving us the minus 15x. And then negative 20 times positive 5, negative 100. So we said x minus 20 is 0. We get x equals 20. And x plus 5 equals 0. So isolate the x to get x equal negative 5. And remember, every argument in the original problem must be positive. So no matter what you plug in, that number has to end up being positive. If you take 20, 20 is positive. Okay. 20 minus 15, is that positive? So 20 is okay. What about negative 5? No. Immediately the argument is negative. Cross it out. As soon as you plug negative 5 into either of these, well, in fact, both of them are negative. So we mark that one out. We say negative 5 is an extraneous solution. Our only solution is 20. Now, look back over. Make sure that your answers don't make the number after the logarithm negative or 0. Usually it's the negative you got to worry about. And usually that just means if when you get your answer, if I were going to, odds are it's the negative that you're going to mark out. Not always, but you don't. It's rare for you to have to mark out for you to mark out a positive and keep a negative. Okay, but it could be rigged like that.
Do you ever have two answers? And if so,
You could, if this had turned out to be a positive 5, no, it wouldn't have been. It'd been a positive 5. It is theoretically possible to have two answers. Okay?
Okay, and you just separate it by a comma?
Yes, I think, is that how what does it say to do? Surely in the instructions it would have said something like separate, simplify, type the integer, use a comma to separate answers as needed. So we now know how to solve an equation, a logarithmic equation that has one log on the left, a number on the right. That was problem 5. We know how to do number 6, where there's two logarithms on the left, a number on the right.
Now number 7.
Number 7.
I'll take over for a while. You've been waiting. I think your microphone has died anyway, Tony.
Not bad right there? Yeah.
It comes and goes.
It comes and goes. I brought mine home with me to put a new battery, and it must have fallen out of my briefcase on the back seat of the pickup. Okay. Common log of 6x plus 2 is equal to 1 plus the common log of x minus 4. Well, our ultimate goal is to get the equation in the form log equals a number, and then we can cancel out the one logarithm that we have. Well, we'll use a base of 10, but I think the problem is that we have logarithms on both sides. We can get equals a number, by taking this second logarithm and moving it over to the left. What we're trying to do is make number 7 look like number 6, where you had 2 logs equal a number. If we have 2 logs equal a number, we know to condense and then use inverse functions to cancel out the log notation. So here we have the log of 6x plus 2. Move that over, that plus is going to become, so a minus log of x minus 4 is equal to 1. We now need to rewrite this as a single logarithm. Log of 6x plus 2. What?
Will there be a fraction bar?
Will there be a fraction bar? There'll be a fraction bar. Now, Mary Mabel, you saying to draw the fraction bar and then the 6x plus 2 and the x minus 4. If the logarithms are added, you multiply the arguments. That's what we did in number 6. If the logarithms are subtracted, that's when you divide the arguments. Any questions in our logic?
This is the condensing logarithms. This is a very good problem-solving strategy. Make it look like number 6.
Okay. What did y'all say the subscript was? 10. So I'm going to use a 10 to the log equals 10 to the first power. Realize that's a little assumed subscript of 10, and 10 to the log cancels out, leaving us just 6x plus 2 all over x minus 4 is equal to, what have we got on the right? 10 to the first power is 10. Any questions on our logic there? We know how to solve equations with fractions. I want to get rid of that fraction. What am I going to do?
Multiply it by x minus 4.
Okay, multiply both sides by that denominator, x minus 4. Multiply by x minus 4. The x minus 4's cancel, leaving me here on the left side.
So it'll be 6x plus 2.
I agree. Equals 10.
Yes. Oh, no.
10x, remember you got to distribute, minus 10 times 4. You were just going to say 10 times x minus 4 and make another step. She was just going to say 10 times x minus 4 and then make a separate distributive step. So I'm feeling lazy. I put it all on one line. Okay, so you say subtract 2, and what else did you say do? Subtract the 10x, 6x minus 10x gives me 6x minus 10x gives me a negative 4x, I agree. And then y'all said, what are we doing with the 2? Okay, negative 40 minus 2 gives us a negative 42. And then,
Yeah, if you moved all the x's to the right, you'd have no negatives. Oh, sure.
yeah,
I was just like, I don't know what.
to give us x equals, negative divided by negative is positive. We can cancel a common factor of, not 4,
Smaller.
2. I think 2. 42 divided by 2 is 21. And 4 divided by 2 is 2. Well, let's make sure, remember these things here. Everything that follows the argument of each logarithm has to be positive when you plug this number in. So what is that? 10 and a half? I'm going to think of it as a mixed number. The exact value doesn't matter when checking. Just make sure that the argument's positive. 6 times a number bigger than 10 plus 2. Is that positive?
Yeah.
Yeah. What about 10½ minus 4, is that positive? So all you got to do is just verify, convince yourself that both arguments are positive.
Now, it's possible when you're doing number 7, your answer might wind up as 3. If you had one, like, if it had turned out to be 3,
Would 3 be an acceptable answer here?
it'd be okay here, but not there. Okay?
That's right. So be careful. You could get a positive number that you as an answer that you have to cross out.
21 over 2.
I didn't catch that last part. When do you have to cross it out?
If the number you have makes any argument,
Here's my math.
the thing after the logarithm, be
Jim,
negative.
You're painting, and I can't see how to get over.
Oh, you got to do it. Where is it?
Y'all see it?
Oh, there it is. Oh, goodness.
Okay.
The number you're plugging in, it has to make each logarithm's argument positive. The argument is the thing that follows the LOG or LN notation. So suppose we got an x equals 3. Well, that's okay there, 18 plus 2, but what about here?
Right.
Okay, so it is possible you can get a positive number that would still need to be discarded.
It doesn't happen often.
Pardon? Then that would be the empty set, correct?
Thank you.
I remember last semester saying to a class, I've never had it give me an empty set on these, and I always assumed you couldn't, but then I had a student come up and show, look, it had like 2 or 3, empty set, and so I was thinking about none of them are going to turn out as empty set, but it just happened that mine didn't turn out with an empty set, but it could happen.
Of course not.
I think it just depends on the people that,
Whether Pearson likes.
Yeah, if you say bad stuff about Pearson and cuss and grumble about doing your homework, then Pearson gives you bad problems. But someone like me that... I forgot about that. Did I start back recording?
Yeah,
Oh,
I
yeah.
was looking over.
I paused that thing half an hour ago. It would have been terrible if I hadn't started recording. Hey, look at this. We have the equals a number. Okay. There's really only one correct first step. What is it? It starts with a C.
Condense. Yeah,
Condense, okay. And then take the base, okay.
I'm definitely going to have to do the other part of that if that's one.
X plus 2 and the X minus.
That's a difference of squares, isn't it? Okay, but what am I going to do? Do I need a fraction bar here? No, because the fractions are being added, so we're not dividing. If we don't divide, the only other possibility is...
Oh,
yeah.
shoot, that's my fault. I'm here looking at his work. Okay.
Okay. I normally make much better braces than this. Look at that. Okay. I've had 50 years to practice them, so I've had more time to practice them than y'all have. What are we going to do to the x plus 2 and the x minus 2? What did y'all say? We're not dividing because they're added. We multiply x plus 2 times x minus 2. And then we're going to cancel out the log base 2 by doing what? Whatever that subscript is, we put a 2 and a 2. 2 to the log base 2.
X squared minus 4 equals 2 with it.
Okay, so you're foiling that out. X squared, and it's a minus 2x plus 2x and a minus 4. We FOIL out the x plus 2 times x minus 2, and 2 to the 5th,
Got to say 10.
32. I
32.
agree.
We multiplied out 5 2s. That's sort of like 4 times 8.
And notice Mary May was saying x squared minus 4. She was those x terms right there, but those 2 and negative 2 cancel out. Ah, okay.
It's a positive, negative.
Okay, so it's 2.
Mhm.
Yeah, not 5
That's
squared,
right.
it's 2 to the 5th.
I keep
Okay?
mixing that up.
And that's a common mistake.
It's an x squared, so I think, now that we talked about difference of squares, I think I'm going to move this 32 over to the left and combine it with that minus 4.
I moved the 4 over into square root method.
Okay,
Never had a
you wanna
chance
do that?
Square root method.
So 32 plus 4 gives us 36.
Take the square root of 6.
Okay, but remember there's something else. When using the square root method, it's more than just a square root. What else do we do? Something squared equals a number. Something we pick up other than just the square root.
They're not wanting to say plus minus.
Plus minus.
Why are you not wanting to say plus minus? Do we have two answers, positive 6 and negative 6?
That's right. That's why I was going to factor it, because then we'd clearly get both of those numbers. But is negative 6 okay? Negative 6 plus 2, is that result positive?
That's just going to be the 6.
It's just going to be the 6. Any questions there?
That's what I wanted to use the square root method because we never use square root method. And any
Okay.
questions? I think we're going to get it done on time today. Problem 9.
Oh, I like this one.
I usually use this a lot.
No, actually,
No. I don't like it in a way, though. There's something I like about it, and there's something I don't like
well, I
about
wouldn't
it,
want two
okay?
different logarithmic bases because,
So that one doesn't have an L in it, it's just an N.
oh yeah, n is the variable. It would have been better if they just used the x here. Okay? The bases are 3, and I'm sure you can tell the difference between it and the others, the way this one goes log, log, whereas the other ones there were no, yeah. You're going to just sort of, you've got to isolate the n. So start peeling off the logarithms.
I claim this problem is already in the form that we need. Single logarithmic term equals a number. You don't have log plus log. You don't have log minus log. It's not like that. I can get rid of this log base 3. This black log base 3, I'll put a 3 as the base of the exponent. And that 3 to the log base 3 will cancel. So we have a log base 3 of n equals 3 to the first power is 3. Did y'all follow our logic there?
Did you do it again?
Then do it again. Correct. Okay, we still have a base of 3. Put another, and it's already in the desired form. Single log equals a number. What's going to happen on the left side? So we just have n equals
Don't say 9.
3 cubed. That looks funny. I'm going to write it like that. 3 cubed, which is 27.
Yeah,
Here-
I remember that on the
There's the argument. Have you put in a 27? Is that argument positive? Yes. Now, if you've gotten a negative number here, there's just no way that could have checked. Because the argument's just a letter. So whatever you got here, it better be positive when you plug it in for the argument.
Wow. Wasn't that bad. It looks a little strange. But I guess the people new to this,
It all looks
they all look
strange.
strange, right?
That's the easiest one you've done all day.
Yeah,
It probably
might
has
have
been. I would have liked it better if there'd been a log base 3 of log base 2 of n.
But when do you have those bases mixed like that?
You
It'd
don't,
be a
you
good problem,
don't.
but
But-
realistically, it wouldn't happen. This is number 10. The last one before the review starts is review problems. So,
Oh.
and is it even is it new? Is it a new problem type, or is it one like what we've already done?
That looks like something you've already done.
It does. I think it might be problem
No, we don't do that.
6.
Mm-hmm.
So there's 5 review questions?
Yeah. I mean,
Looks like there are 5 review
yeah.
questions.
Oh, we always want 15 Oh, do I remember that? The domain of f is equal to the.
No, the domain is equal of f is the range of f inverse. Yes.
The range of f is equal to the. Now, why am I doing
Tony,
this?
why are we doing that when we're trying to do?
Okay, go back to number 10. But number 10 is very similar to I thought it
Number
was
6. Yeah.
Okay, so on number 6 it's log base 10. Here we have log base 4.
There's only one correct first step. Okay, condense. I agree.
So, will there be a fraction bar? No, because of that plus.
Oh, switch
Oh,
over.
That you put the 4.
There.
Yeah?
So we have the log base 4. Do I need a fraction bar? So I'm not dividing. The only other thing I can do to arguments is to, if you're not dividing, you have to multiply x times x minus 6. Okay, well, let's get rid of that log base 4. We're turning all of that black stuff into exponents. What are we going to do to cancel out that log base 4?
You're going to put a 4.
Okay, so we're using the exponential base 4. 4 to the log base 4. Inverse functions perform consecutively. They're canceling each other out.
And then you get x squared minus 6x equals 16.
Okay, I agree.
Y'all hear that? X squared minus 6x equals, don't say 8. 4 squared is 16.
And then minus 16.
Yep, that's written in standard form for a quadratic equation. And factor.
X squared. What do you know about the signs?
82.
Oh,
Okay, well, it's a simple trinomial, so choose the pair that adds or subtracts to give you a 6. In this case, it has to subtract. So what did you say?
8 positive 2.
I agree. Y'all agree with that factorization?
okay. Set
So-
each factor to 0.
To give us x equals positive 8.
8. Yeah. The other one's
8 is positive. 8 minus 6, is that positive? Yes. What about this one? Right off. Negative 2, not positive.
Usually it's the negative numbers you mark out.
Not
Before
always,
last
but
semester, you know, I would have been saying, oh, I don't think there'll be any of the empty sets, but nope, I was wrong. Which one was it? I forgot.
8.
8.
Any questions there? If you're in my class, realize, unless you're just going to watch those real low-tech videos, you'll need to go to the playlist to see today's video. Now, if you're in Tony's class, no one had clicked on the assignment, so I was able to actually edit.
I have the better students that do not work ahead.
my,
And you have the good students that are
my students have worked ahead, and so I'm not able to add in the videos.
I'm like right online right now. But I just missed Monday, so I'm kind of panicking.
Oh,
Okay,
But
then you
every
stop
single
recording.
time-
Stop recording.
Okay, here.